doi 10. 4324 9,781,003,255,529 is 5. The business relevant details behind AI and cloud technology introduction is highlighted in Chapter 1. The increased criticality of technology to the success of a business has led to the creation of a variety of C-suite technology roles. In fact, 40% of CEOs said their CIO or tech leader will be the key driver of business strategy, more than the CFO, COO, and CMO combined. This concentration on the CIO as the critical transformation driver runs at odds with our research on the key success factors for AI and cloud-enabled transformation. Our research highlights the need for these transformations to be business-led. We believe that, in this technology-driven world, most non-IT executives and board members would benefit from having a de minimis level of technology literacy to enable business leaders to actively engage in discussions associated with technology-led transformation. We believe these discussions need to focus initially on business end state and then work down to the technology enablers rather than work up from whatever new technologies might exist at that point. By technical literacy, we mean that every executive and board member should know at least enough to effectively contribute to insights and strategic decisions concerning digital transformations, technology investments and business model considerations. The Forbes Technology Council too has provided some guidelines for this, and we note that they recommend knowing what coders do and what coding actually is. Executives do not need to know how to create code, but it helps if they know what is involved, know what the capabilities and performance parameters are, and can converse with technical people, so as to ask them the right questions, for example during a presentation or in approval processes for resource allocation. This is required to break down traditional barriers between the mainstream business and the techies in the business and build a bridge from the business towards those who are deeply immersed in creating the technology. 122 The business relevant details. This educative lift of achieving technical literacy in the board and executive will foster a digital mindset in those who collectively straight eyes and take the way forward. It is not difficult to garner enough information to become literate in these technologies. Perhaps the most efficient way is to watch one or more YouTube tutorials 3 on AI, cloud and other technical capability elements as appropriate to the company's context. The footnote links some further learning opportunities tutorials, many of which have been viewed over 1 million times. They bring familiarity with terms, definitions, capabilities, and constraint. To conclude this discussion, we note that the business transformation choices need to be informed by knowledge of what is possible, feasible and ultimately valuable. A prerequisite for effecting this must surely be technical literacy across the board and leadership C-suite team. The purpose of this technology overview is not to enable business leaders to become business coders, or even to give detailed technical requirements to technologists and data scientists, which may cause more confusion and frustration. Our goal is to create a logical and intuitive description of the major innovations which we're describing as the building blocks for AI and cloud innovation, without losing technical fidelity or using abstract analogies. We also want to bring to life our claim that there is a positive interplay and multiplicative benefit when AI and cloud technologies are considered together. Our goal is to allow technical and non-technical people to get on the same page as one another, and to allow everyone to have an understanding of what these innovations can practically provide to them, in a structured, buzzword-free way. We will give an overview of each of these major innovations through this chapter, but first, we will cover a range of relevant trends which have influenced the way in which technology provides value to an organization, and the way in which the technology capability has needed to evolve in recent times to take advantage of these trends. Working hard for the benefits as technologies have matured, costs have decreased, and the underlying capability has increased. The predominant drivers of these costs and capabilities are computation power and the storage and manipulation of data. These fundamentals have exponentially improved for the last 40 years. For example, Moore's law predicts the doubling of transistors in a CPU every 18 to 24 months, which has also led to a 20–30% annual reduction in the cost per transistor over time. Storage costs have halved roughly every 3 years, as their underlying speed has continued to increase. These underlying cost reductions are the main drivers for the transition from mainframes, eventually to the ubiquitous appearance of PCs and other mobile computing technology. Despite the enormous expansion in technology use, THEV Business Relevant details 123 underlying IT labor expense, when well managed, has dropped to a fraction of its previous costs. Facebook often cites the example of having over 1 million users per engineer in 2009 as a measure of its technology efficiency. So, the good news is, without doing anything, organizations should expect continual capacity and capability improvements in large areas of IT spend. For organizations that are already leveraging cloud-based services, there are additional ongoing benefits from the security, performance and capability enhancements that they provide as they periodically update their platforms. These benefits come from multi-billion-dollar investments that the providers are making into their platforms. Unfortunately, capability doesn't automatically translate into outcomes. In particular, there are a few obvious but important steps that need to be taken to ensure that the promise meets the reality. Executing new technology-enabled business models will increase the computation and storage requirements of a BUSIN. While the cost of innovation has reduced significantly over time, these new costs, and the cost of change both upfront and ongoing, needs to be understood and thought through carefully. The IT operating model needs to fundamentally change to effectively manage a range of more complex third-party relationships, shift the skill set of the technology function, and appropriately govern the shifting risk environment, especially with respect to data governance, data security, and effective ongoing management of statistical models. More powerful computers, with more data, don't automatically give any new insights to a business, nor do they change the underlying way a business model creates value for its stakeholders. Some historical technology innovations had obvious business impacts, e.g., moving from fax to email technology. The breadth and complexity of the potential AI and cloud technology capabilities lead to a far greater range of potential considerations than ever previously exist. Capturing this value requires a proactive effort from business stakeholders to better understand the way these technologies can support their future needs, and from technology stakeholders to rethink the way in which they create value for the business. Supervised learning models, often also called predictive models, describe a broad range of algorithms that have been in use in business and scientific areas for the last 40 years. These include generalized linear models, GLMs, decision trees, random forests, and a wide range of more specialized models. All of these models have a common mathematical goal. They all use a range of variables called independent variables, because they should vary independently of each other to predict a single outcome called a dependent variable. The relationship between the dependent variable and all of the independent variables differs based on the type of underlying mathematical model. We won't cover the 124 business relevant details differences between those variables in this book, as in our view, that level of technical detail isn't required when making a business decision. What all these models have in common is that they will use a given data set, fit the formulae, and predict the outcome as best it can. The machine will provide the most accurate fit between the dependent variable and those independent variables, where most accurate is defined by the underlying mathematical model and its definition of statistical error. An example of how these models have made an impact in businesses in the prediction of loss for insurer. Expected loss is a key but not the only factor in insurance pricing, and as such, a more accurate model better manages the risk exposure of the insurer and can be used to positively select the most attractive customers to the business while adversely selecting or pushing away undesirable customers onto the competition. While these algorithms have also been adopted in a vast range of other applications. For example, predicting sales of a product or predicting volumes in a call center, the main innovations that have made this possible have been an increase in computing power, an increase in the availability of data both internally and from third parties, far more intuitive programming software, and the ability to integrate these models with other applications. The cloud is not singularly responsible for the increased use of these algorithms, but it has made their deployment significantly easier, thus reducing the cost of innovation. This is one of the reasons why we see a multiplicative benefit in the innovation provided by these AI models and cloud platforms. Unsupervised learning. Unsupervised learning, often known as clustering, is focused on finding patterns and grouping within data, without a focus on any outcome at all, as opposed to supervised learning. The algorithms that underpin unsupervised learning include k-means, principal component analysis, self-organizing maps, and various others. Unsupervised learning is best thought of as a hypothesis test, which presumes that there are a set of meaningfully different groups within a range of given data. For example, you may assume that there are 6 meaningfully different types of customer in your sales data. The hypothesis would be framed as follows: I believe that there are 6 different groups in this data set which contains their ages and incomes. The algorithm then combs through the data, developing that set of 6 different groups in a way that they are as different as possible across those groups of age and income. Given the criticality of better understanding data and making more tailored decisions, this can provide significant benefits. Often, these algorithms are part of a process, for example a customer segmentation which categorizes types of customers by their buying and product preferences, which then feeds into a supervised algorithm to provide more appropriate product recommendation. Like any categorization problem, unsupervised learning can suffer from the desire to develop one segmentation to rule them all, where a single clustering business relevant details 125 definitio. N is used in a wide and poorly related set of contexts. While well-intended, this can often result in suboptimal business outcomes. Deep learning, and the neural nets we never want to speak about again. It would be negligent to begin a description of deep learning's innovations and value without a brief overview of the simpler neural net algorithms that preceded them. The intent of this background is to provide context and an appropriate level of caution for the use of neural nets, even though the authors of this book find tremendous value in them when used appropriately. Neural nets all have a logical structure that is conceptually designed around the structure of a neuron in the human brain. Neural nets are the underlying building blocks of a range of models, both supervised and unsupervised, and they became particularly popular in the 1990s. At that time, the available computational power, together with the mathematics known at the time for fitting these models, did not allow of particularly sophisticated models. However, they still offered some significant potential for improvement over the incumbent model. The trade-off that gets made against more traditional models, e.g. GLMs, is that a neural net doesn't contain any intuitive explanation for why the model is working in the way it does. Instead, the users of neural nets have to be satisfied in the understanding of how accurately the model predicts e.g. how many times out of 1,000 a model will correctly predict the breakdown of a machine part without understanding the reason why it correctly or incorrectly predicts that outcome. Due to the lack of understanding of how these models work, a range of appropriate management systems are required to address the impact of misclassifications and misprediction. Several businesses using these models in the early 90s threw some of this caution to the wind, resulting in significant financial losses and a reluctance to use these models in mainstream business application. Despite these early setbacks, research in this field continued. In 2006, mathematicians developed more efficient ways to train neural net models, allowing them to become significantly more complex, and to develop multi-layer models commonly referred to as deep learning models. These models were able to outperform the existing ones and, more importantly, have been able to outperform humans in addressing many problems. This led to the understandable excitement around the use of these models in all aspects of everyday life, which we will highlight in a set of limited overviews of the most common deep learning applications. Image recognition, manipulation, and convolutional neural networks, CNNs. Image recognition and manipulation is a highly complex area of computer science. Traditional programming approaches aren't suited to the wide variety of ways 126 the business-relevant details in which image data is provided to a computer. For example, when reviewing and classifying images, algorithms need to control for differences in positioning, lighting, distortions, and a variety of other real-world disruptions. These disruptions are hard to program for. As such, until the advent of sophisticated CNNs, most image recognition techniques were a poor substitute for human intelligence. Now, deep learning CNNs provide the most accurate classification of images, well beyond human capability. As a practical example, CNNs can use the image of a person's iris to accurately predict their gender, age, and ethnicity, something that people can't do. and something researchers don't fully understand how the algorithm designed. Practically, these developments have led to a range of novel applications, well beyond the initial test of what is in this image. These models can perform facial recognition, create text from images of documents, turn satellite imagery into detailed land use information, and identify tumors in MRIs. Amongst a wide variety of other classification outcomes, these algorithms have also allowed for manipulation of data, including filters, to beautify or change images and video, including deepfakes, which generate intuitively accurate but fake videos of people. These have been used to create viral memes and underpin the growth of new platforms like Instagram and Snapchat. From a business perspective, the key aspect to understand is that a far wider variety of data can be practically used when making business decisions or developing new solutions to old problems. This enables a range of new innovations to be created, and in particular, the development of business models which can interact with new channels of information that were previously uneconomical or impractical. Importantly, some of the algorithms that would have previously required a team of data scientists to develop are now available as a service. This has also dramatically reduced the cost of innovation. For example, Amazon's Rekognition Cloud Service 5 allows you to send an image or video via a simple API and will return a range of structured data. This can include novel items like whether the image contains a specific celebrity. But it can also be used for much more mundane but practically important work like confirming the use of appropriate PPE on a job site or identifying unsafe or inappropriate content. Amongst other practical use, Google offers a similar capability on their machine learning platform and had open-sourced TensorFlow, a powerful set of algorithms with a similar set of applications. This is yet another aspect of how and why the impact of AI is being amplified by cloud platforms. Chatbots, natural language processing, and neural natural language processing understanding the underlying meaning and context of a sentence, let alone a paragraph or document, is clearly a challenging task, especially obvious to anyone who has spent time teaching children how to read business-relevant details. 127 Like the example of image recognition. Traditional rules and procedures are not a practical or accurate way to ensure the appropriate understanding of text data. This is another area where deep learning through neural natural language processing (NLP) has spurred a whole wave of innovation, particularly the development of chatbots. While this is still a developing area, a well-implemented chatbot can address a range of customer inquiries far more conveniently and cheaply than a person. While previous examples of voice-guided systems were clunky and forced customers to adopt the organization's singular way of interacting, neural NLP techniques enable a much more diverse and human-centric way of interacting. The growing power and flexibility of simulation and digital twins business, financial and operational simulation techniques have existed for decades, originally focused on developing a simple best estimate of the likely outcome, e.g.,
financial forecast.
These forecasts were developed at a reasonably high level of aggregation and used a coarse range of assumptions. Over time, new algorithms were developed which were more flexible and allowed for the incorporation of new sources of data, for example consumer confidence surveys. As the breadth of inputs and assumptions in those forecasts increased, there was a corresponding increase in the accuracy of the forecasts. Subsequently, the concept of scenarios came into being, whereby a range of forecasts were developed, using the realistic range of potential input assumptions, for example, the range of potential consumer confidence survey results for the periods in question. The main technology innovation in simulation relates to the scale and complexity of simulations being run, which are now digital twins of real-world system. For example, Airservices Australia runs a simulation engine that creates a digital replica of Australian airspace, including all of the aircraft and weather within the airspace. This cutting-edge digital twin can be used to more accurately predict, collaborate and respond to the changing requirements and requests, enabling highly precise predictions and effective data-driven decision-making.
Airservices Australia 2206 in addition.
Advancements in data visualization and manipulation have enabled the development of human-in-the-loop interfaces to interact with those simulations and make better real-world decisions in near
time.
In the Airservices example, modeling suggests a potential 33% reduction in delays due to improved decision-making. The ability to run highly complex, Digital twin simulations has great applicability in areas where the environment is highly variable, and there are sure 128 the business relevant details terma end or downstream implications to on-the-ground decision-making
G.
Supply chain operations. As a simple example, many manufacturing sites already collect real-time data through SCADA systems, which provide a rich source of detailed information around production, faults and bottlenecks. If one subset of the manufacturing site shuts down due to an unexpected fault, a simulation of the downstream impacts might look at the variety of available options for the operators and suggest a change to the daily production plan to ensure that customer orders aren't missed. And that overtime labor is minimized. While the concept of a digital twin is highly sophisticated, the barriers to developing these simulations have reduced significantly through advances in data collection and transformation, simulation software and data visualization tooling. Strong AI and the AI control problem. As the various AI and machine learning technologies have emerged, so have concerns about our ability to control machines. To quote Elon Musk in 2014, we should be very careful about artificial intelligence. If I were to guess what our biggest existential threat is, it's probably that, with artificial intelligence we are summoning the demo. In all those stories where there's the guy with the pentagram and the holy water, it's like he's sure he can control the demon.
Didn't work out.
These existential concerns relate to a type of AI research under the umbrella term of strong AI, or artificial general intelligence, and are important to separate from all of the aforementioned AI, which are categorized as weak AI, or narrow AI. The primary demarcation between these AI techniques is the concept of consciousness and, critically, the ability for the creators of these algorithms to lose control of the technology as the algorithm begins to make its own decisions. There is an ongoing debate about how much concern our society and government should place on strong AI. In our view, these considerations should not factor into current planning, as the technology is both unavailable over the medium term and still being defined. In contrast, we recommend that all organizations seriously consider the ethical aspects of narrow AI as they develop new candidate business models. The practical reality: it would be easy to look at the various marketing buzz around AI and big data and assume that these new, magical models will somehow trawl through large swaths of data and suddenly provide the business with gold nuggets of insight. Business relevant details 129. There is a structured, hypothesis-led approach to data analysis, which needs to be followed to ensure that the reality of these technologies lives up to the hype. The two major model development risks we would like to highlight are that, 1. If you torture the data enough, it will say anything you want it to. Robust statistical modeling relies on a structured process for testing and developing models and underlying assumptions which can be manipulated or unintentionally omitted. It's critical for this testing and deployment process to be part of any business deployment of AI techniques. The bottom-up, hypothesis-free approach to model building is highly likely to find lots of insights that don't result in reliable outcomes in the real world. This comes through the risk of statistical overfitting, where models unintentionally fit to random noise, which is a part of all data rather than the underlying signal.
2.
To accurately predict something, you need the right data, not just lots of data. This is where big data can become a distraction and is often one reason why these models don't live up to their hype. Moreover, correlations within a dataset do not necessarily translate to a causal relationship. Incorrectly making that assumption can lead to incorrect business decisions. While this isn't a book about model development best practices, the authors have strong views on the ways in which human insight should be incorporated into the data collection and feature development process, and how model accuracy needs to be assessed to ensure the delivery of benefits. These risks are not intended to act as a roadblock to better using data in an organization. In practice, the hypothesis-led approach is also helpful in giving a structured understanding of the requirements and limitations of the existing organization's data for a particular use case. In contrast to a more generic view of, we need more data, or, we need cleaner data. In addition, there have been significant improvements in the use of external data, either to validate or correct problematic internal data or to supplement internal data by giving a broader, more comprehensive view of the environment in which an organization operates.
For example,
Retailers are now able to leverage mobility data sourced through mobile phone network operators to understand the volume and demographics of the people within walking distance of their stores to better measure their performance and optimize their staffing. In addition to the model development process, there is a need to methodically manage the deployment, ongoing management, and update of statistical models in a production environment. Those disciplines are typically covered in an MLOps machine learning operations capability, for which there are many helpful references and reports. 8. The key points to highlight from a business context is that any model is a point-in-time reflection of the data on which it's been built. As such, 130 the business relevant details 1. It will be susceptible to bias risks, which needs to be measured and tested using standard statistical processes and business sense checking.
2.
It will need to periodically be refreshed and enhanced, as data can become out of date, statistical correlations can drift, and more relevant data becomes available. Thinking about cloud in the context of competitive advantage as technology became more and more important in the past 40 years, IT departments had to be developed to take on the enormous task of developing and running IT platforms. The traditional model of IT reflects a need to manage everything from building and managing hardware, including networks, servers, and storage. This includes the ongoing effort to fix devices on short notice, upgrade hardware as requirements change, manage an inventory of assets, etc. Manage the safe and secure collection, reconciliation, and management of a wide range of data. In recent years, this has become increasingly complex due to the increasing threat of cyber attacks and privacy breaches. Installing, upgrading, debugging, and patching systems, from the core operating system through to a broad range of applications. In recent years, this workload has increased as end-user expectations have grown, especially as people interface with technology across multiple channels. In contrast with traditional IT, cloud-managed services provide various versions of those capabilities through third-party management of Figure 5.1 Infrastructure as a Service IaaS, where the core technology infrastructure is provided and managed by the IaaS provider, based on a flexible set of requirements that can easily and frequently be adjusted to suit the needs of the business. Platform as a Service PaaS, which builds on IaaS by including a layer of functionality for highly configurable business application. For example, a PaaS can include an ability to connect databases into machine learning models, which can then be deployed through flexible web interfaces. Software as a Service SaaS, which continues to build on PaaS by offering a best practice application solution to specific problems,
E.
a pre-configured solution to a business problem. The diagram below describes the varying responsibilities in business managed versus cloud service supported technology. This raises the obvious question of what capabilities should be supported by fully internal IT versus each of the cloud service options. The appropriate solution depends on the unique service requirements and should be assessed on business relevant details 131 case-by-case basis. An oversimplified but helpful approach for conceptualizing these decisions is that, in SaaS solutions, you're essentially getting the same service that everyone else is. In some functional areas, the adoption of a relatively rigid, best practice-based system could be great. For example, HR processes are complex and expensive to develop and manage with homegrown solutions. In addition, they are rarely a source of competitive advantage. This is where SaaS providers
D.
Workday's HCM suite can offer a significant advantage by providing best practice solutions for managing payroll, training, leave, and people administration. For PaaS solutions, you are able to leverage capability from third parties, but the configuration and tailoring of that solution is up to you as the designer. That ability to tailor is a critical element of developing a practical competitive Figure 5.1 comparison of as a service model's source, adapted from SHO 2018 SHO D.
2018 28 September Cloud Service Model IaaS PaaS SaaS Diagram Dato https://dato GitHub io 2018 09 28 Cloud Service Model
HTM 132 The business relevant details differentiation and is the primary reason why we believe PaaS solutions have a broad, sector-wide ability to differentiate organizations at scale. In some cases, The unique capability being developed cannot be supported by PAWS offerings and may require IT to take ownership of some or all elements of the stack. For example, an organization may wish to deploy specialized processes and algorithms that can't be configured with sufficient performance in existing PAWS solutions. Viewing cloud services in the context of building blocks of capability regardless of the choice of cloud service. There are a set of implicit capabilities from third-party cloud providers, the management of security updates, bug fixes. Patches and other IT best practice can often be provided more efficiently through specialized, highly scaled providers like Azure, AWS and Google. It's not to say that internal IT can't provide these services, though it tends to be far cheaper and more effective for an organization to leverage these capabilities from a third party.
Given their enormous scale advantage,
Simplifying development and orchestration of solutions by leveraging the investment that cloud services providers have made into PAWS and SaaS solutions.
as above,
An internal IT organization may be able to provide similar services but will almost always have far less scale and cost efficiency that could be gained through the major hyperscale platforms. The ability to rent services and flexibly scale requirements, significantly reducing upfront cost and capital expenditure. This is most evident when developing new services or expanding into new geographies, as you can leverage the availability and capacity of the cloud provider's investments. Rather than making your own, this has been critical to scale applications and streaming services, or to manage seasonal variations in computing requirements. The ability to connect between cloud platforms and existing systems, through the use of clearly defined APIs, application programming interfaces, and microservices. The definition and impact of these are covered in detail below. APIs and simplifying doing business. An API, otherwise known as an application programming interface, is best thought of as a standardized way of communicating between machines. The system specifies, in a standardized and openly accessible approach, what services, process or data it will provide a requester. If that requester follows a specific process laid out by the system. While this seems like simple, common-sense logic, APIs are a relatively recent advancement, and have become critically important in many transformations. The business-relevant details 133.1 Simple assumption made in this book is that the reader agrees on the benefits of having situationally relevant data at hand when making a business decision. For example, knowing when a customer is having an issue in the service being provided enables a customer service operator to reach out and resolve the problem. Together with this assumption is the implication that data can only be valuable when it is provided to relevant parties in a situationally relevant way, at an appropriate time. To that end, APIs and microservices are the backbone of simplifying the flow and manipulation of data in a modern organization, or even between organizations. APIs are seen as a reducer of business friction, with little to no downside. This trend has led to the increased use of APIs both within an organization to drive efficiency, and external to the organization, to drive growth through the creation of new products and service. The most well-publicized push to drive up the use of APIs in an organization is a legendary API mandate email that Amazon founder Jeff Bezos allegedly sent in 2002. When all teams will henceforth expose their data and functionality through service interfaces. 2. Teams must communicate with each other through these interfaces. 3. There will be no other form of inter-process communication allowed. No direct linking, no direct reads of another team's data store, no shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. 4. It doesn't matter what technology is used.
HTTP, CORBA, PubSub, Custom Protocol doesn't matter.
5. All service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world.
No exception.
6. Anyone who doesn't do this will be fired. Jeff Bezos. 9. It's important to recognize the difference between the use of APIs and the communication systems that preceded those standard. In the not-so-distant past, information sharing wasn't standardized due to the use of proprietary systems whereby the provider often had an incentive to avoid interoperability and the lack of commonly accepted standards for
machine-to-machine interface,
This lack of interoperability means that a range of legacy systems will often require significant and expensive integration programs to enable now basic, reliable connectivity between systems. In contrast, APIs typically run on common, web-based standards and can be thought of as digital contracts, as in bridges, between systems. For example, the Australian Open Banking API standards describe the way a message can be sent to a bank with a supporting security token and authorization 134. The business relevant details to Rex. T. The balance of a customer's account. The format and structure of that response is a clearly and consistently defined message, which the recipient can then convert into business relevant insights. That standard doesn't change depending on which bank you're interfacing with. And the open standards being used significantly reduce the cost of these integrations when compared to prior alternatives. Open banking is an example of a centralized API ecosystem, whereby a central authority has defined the way in which interactions will occur between multiple operators. For the purpose of realizing a specific objective, DBS Bank in Singapore runs a centralized API ecosystem 10 with the objective of simplifying the delivery of a broad range of customer services that would traditionally involve complex integrations. W.
IT Banking System G.
Payment processing, loyalty rewards payments. This ecosystem allows DBS Bank to maintain relevance to customers in a complex and changing environment by leveraging the investment of many other third-party operators that benefit from the simplified integration from following DBS Bank's API standards.
Alternatively, Sequence API ecosystem are an approach to define more traditional value chain, where the assumed customer journey has been broken up into states,
each with an assumed set of inputs and output.
IEA Group Our Real Estate. Com.
Runs a sequenced API for prospective homebuyers and renters, 11 whereby third parties can integrate common processes such as listing houses, running campaigns, and following up on leads. This integration process helps Ray Group reduce friction with agents, buyers and sellers, who all have to maintain accurate and timely data throughout the sales process. As the barriers for integration are reduced, it's easy to see the way in which different strategic opportunities come about through tighter integration with third parties. For example, customer service can be improved by integrating with logistics providers. For example, by giving live updates on the delivery of a customer's goods, data from sensors and other Internet of Things IoT devices can be integrated into the proactive management of supply chain. In an operations issues, partnerships with third parties can more easily come together to create new and differentiated customer propositions. That's great, but what's the catch? It's easy to look at this chapter and assume that if barriers to innovation are reducing, and the world is simplifying its interfaces, very little could go wrong so long as you're making significant investments in technology. Unfortunately, these innovations also create a range of challenges, including competition will continue to increase as barriers to innovation drop for your organization. They also drop for all others. Therefore, a standard technology-led approach is highly unlikely to yield any lasting competitive advantage. Business relevant details 135. Markets have become more complex as competitors look to innovate and provide greater value to their customers. They will often expand into adjacent services outside their traditional core. Often, this means that you will face competition from new competitors. Moreover, in the example of complex ecosystems like the DBS Bank example, having a tech-enabled business model may become a table stakes customer expectation. Consumers have rising digital expectations, shaped by their best experiences across many suppliers. Too much choice is a bad thing. While the cost of innovation has significantly dropped, the complexity of potential technology innovation has increased exponentially. Historically, business leaders faced waves of common upgrades. Going forward, each organization's technology strategy needs to be tailored in a way that more tightly aligns with their business strategy, their customer expectations, and their business capabilities. Regulators will drive further competition. Traditional value chains and business ecosystems, particularly those in Australia, tend to form oligopolies. One of the purposes of regulators such as the ACCC is promoting the economically efficient operation of, use of, and investment in infrastructure, and identifying market failure. 12. Put simply, the technology innovations highlighted in this chapter are a set of new tools and approaches for regulators to break up these traditional value chains and business ecosystems. Open banking, and the broader open data movement are common examples of this trend. Sophistication needs to increase to capture the opportunity. As platforms become more sophisticated, there is a need to uplift the technical and non-technical capabilities of the organization. For example, there may be a need to employ more data scientists to build predictive models, while also uplifting the risk management team's capability. To ensure those models are sufficiently explainable and meet evolving regulatory requirement. There has never been a time where the technology strategy and its successful rollout has been more critical to an organization's success. While experimentation is a critical capability to help navigate through the potential business model options enabled by these technologies, we strongly caution that experimentation is not a strategy.
โน้ต 1 คาลิด K ฟิลิป A เพอร์ตัน M นาน E 2020 The New CIO Business Savvy Technologies Deloitte Insight Worldwide Web 2 Deloitte Com US N Insight Focus CEO Insider Business S Insight The New CEO HTML2 Worldwide Web Forbes Com Site for Tech Council 2017 03 เศษ 27/11 Smart Simple Way to Promote Tech Literacy
Shish equals 7B47F30F71143 YouTube example introductions for AI W
YouTube.com Watch V เท่ากับ F7OIW www YouTube.com Watch V เท่ากับ S0DM Tag 4CW World Wide Web YouTube.com Watch V เท่ากับ CW9 Tab 8 H5E On Cloud World Wide Web YouTube.com Watch V เท่ากับ 36 ZDugu 16W World Wide Web Yahoo.com Watch V เท่ากับ 36 ZDugu 16,136 The Business Relevant Details including
We note the increasing invested cost of data scientists and engineers.
5 AWS Recognition https:// Amazon.com Recognition 6 Air Service Australia 2020 24 September Air Service Technology Win I Paragon Award 2020 World Wide Web Air Service Australia com Air Service Digital Twin Technology Win Site Paragon Award 2020 7 Tonoti 2014 Elon Musk is afraid of AI Bazzern World Wide Web Bazzern
Com article 46,019 Elon Musk calls artificial intelligence summoning the demon and that's not very reassuring 8 Amanoff B
Faron F Kuder D Smithau N D
MLOps Industrialized AI scaling model development and operations with a dose of engineering and operational discipline.
Deloitte World Wide Web 2 Deloitte Com X N Insight Focus Tech Trend 2021 MLO Industrialized AI HTML9 Applied University 2022 10 March The API Mandate Install API Thinking at Your Command https://appic university.com blog The Appic Mandate 10 DBS 2017 Reimagining Banking DBS launches World's largest banking API developer platform World Wide Web DBS com Newsroom Reimagining banking DBS launches world largest banking API developer platform 11 IEA Group N D IEA Group Partner API Overview https://partner real estate com out documentation Appic 12 Australian Competition and Consumer Commission ACCC about the ACCC World Wide Web ACCC Gov
About Us Australian Competition Consumer Commission about the ICDOI 10 4,324 9,781,003,255,529 6 Innovation Introduction. A large portion of this book is focused on the antecedent capabilities required to develop a new business model.
Powered by AI and Cloud Technology.
In this section, we shift the focus to the innovation approach taken to develop the candidate business model. This section is not a comprehensive guide to innovation, and we recommend readers to consider other books and courses if they want to learn more. For example, 10 Types of Innovation. The Discipline of Building Breakthroughs, 1 or Samson and Gloat, 2 for further detail on some of the themes highlighted in this chapter. The interplay between innovation, transformation and technology enablement. While our book title includes the term transformation, when technology and new business models are involved, this clearly overlaps with the field of innovatio. Innovation can be defined, adapted from the OECD definition, as new or enhanced products, processes, business models or organizational methods that create value for stakeholders. Transformations can be highly or lowly innovative. This depends on just how new the changes are that are being designed, trialed, and implemented. It is also worth considering newness in the context of risk and reward of the technology enablement being considered. If key elements of a transformation are brand new to the world, with perhaps unproven technology or unknown consumer demand, then risk and hopefully reward is reasonably expected to be higher than if a transformation is being done in a local company that is similar to what has been tried and tested multiple times in O.
Versus Market 138 Innovation Figure 6
One articulates the integrated roles of innovation, transformation and technology enablement, as well as the varying impact on organizational growth and returns. Generally speaking, there are a set of archetypes that we have identified in our research and experience, a slow decline of the organization. Due to the limited focus of the executive on only one of these roles, 1. A singular focus on transformation, typically characterized by well-intended focus on reducing waste in existing process. These programs tend to drive a meaningful short-term benefit, but due to their narrow design, do not address any fundamental challenges in the business model and the way value needs to be created into the future.
2.
A singular focus on overhauling technology, often by performing lift and shift of existing on-premise applications and processes to the cloud. Depending on the degree of waste in legacy platforms, this may provide Figure 6.1 interactions between innovation, transformation, technology enablement and business impulse. Innovation 139 some benefit. But the economics of moving from significantly depreciated technology platforms to new platforms without transformation of the business process itself tend to result in low returns on investment.
3.
Innovation theater, where well-meaning and intuitively beneficial innovations are developed, off to the side of the business. Without an explicit path and plan to integrate these innovations into the core business, and to support their scaling with technology, these projects tend to fizzle out over time. The ability to keep up with customer and market expectations by effectively leveraging skills across 2 of the 3 roles. 4. Driving a new way of working, whereby tools and methods in innovation and transformation are both used by the organization to reduce waste in existing processes and also to re-engineer the existing business process through a structured innovation framework.
5.
Adopting a process of market following, where transformation works in tandem with technology enablement to quickly adopt the best technology system solutions seen in market. Following the leadership of other organization.
6.
The development of a successful greenfields business, effectively separated from the core through a separate technology stack and culture of innovatio. These new ventures can be quite successful, but there is the ongoing challenge of how to transform the existing business. Creating breakthrough benefits for the business by appropriately using skills across innovation, transformation and technology enablement. Point 7 in the diagram above. In these examples, innovations at the scale of business model transformation and advanced digital tools are used to enable these outcomes, raising the barriers to entry for would-be competitors. Examples include Netflix and Rolls-Royce, see Chapter 4, where there was clearly a strong sense of innovation in their strategies. These strategies were transformational for these businesses and their customers, and that those innovations were enabled by AI and cloud technologies. In financial services, DBS, Bank of America, and although it was more a fast follower than the leading-edge DBS and Canadian Scotiabank, also qualify as having been innovative, transformative, and accomplished through technology enablement, prioritizing innovation, transformation and technology enablement given the complex range of choices, each with potentially significant execution risk. The answer is not always to immediately seek a highly complex, technology-enabled and innovative transformation program. Some of these risks can be managed with internally controllable risk mitigation strategies
G.
incremental application building, pilot testing, while others can have much larger impacts
D.
consumer acceptance risk and would be expected to provide larger rewards. 140 innovation does not need to be a first-to-market transformer. But indeed it may make sense to be neither on the leading edge and certainly not on the bleeding edge of new technologies, but be a fast follower as a legitimate position for transformation innovation. Scotiabank, headquartered in Canada, adopted such a position, beginning from behind the pack with its digital cloud transformation yet moving towards a leadership position once a sound basis for cloud-based modernization was achieved. With 92,000 employees substantially in Central and South Americas, Scotiabank Bank of Nova Scotia started later than its competitors with AI and cloud-based transformation. Yet between 2019 and 2022 it has moved apace, changing its organizational structure and moving fast to catch up and in some ways overtake the industry average in terms of digital offerings and business model transformation. Having built numerous AI applications efficiently, Scotiabank has taken a cutting-edge approach to open systems developments going forward. It positioned its cloud platform as much more than a way to outsource, a way to modernize its whole organizational business model. This bank has recently won many awards and seen its stock price continue to rise significantly as it transforms, embracing the future and using its new approaches to being value to new market opportunities and geographies. This example demonstrates that a fast follower approach can be very successful, with good returns on effort and investment. Scotiabank's journey demonstrates that a careful and low-risk approach can lead to a successful catch-up, but we stress that this is clearly not the same as a laggard approach. Scotiabank did not do nothing, or just pay lip service to the AI cloud opportunity. It invested well, transformed substantially, succeeded, but wasn't first as the innovator in its market. This example relates well to Australian businesses who can learn from leading-edge international practices. Perhaps the most efficient way to proceed in some cases is not to be the groundbreaker, but to learn and follow the cutting-edge players. Just as some transformations can be highly innovative while others can be lowly innovative, some innovations can be highly transformative for the organization and others not so or less so. For example, when one of the authors was working closely with the top leadership team at National Australia Bank during its very successful decade, 1990-2000. New products such as wealth management were innovated but were not transformative for the bank as the scale of impact was not relatively large. Similarly, a cultural transformation attempted during that period was, while potentially transformative, not really innovative and certainly had nothing to do with advanced or digital technology. The evolution of innovation before delving into the details of how to capture the transformative benefits of AI and cloud technologies more effectively when developing candidate innovations. We want to highlight Innovation 141.1. The business model is defined as the way in which the organization or a functional part of the organization creates, delivers, and captures value. At this level of abstraction the focus is on the what, rather than the how, which therefore excludes incremental improvements which are often done at the operating model level. For example, switching to a lower-cost provider of a service which isn't materially different to the incumbent service provider.
2.
Business model innovations can be internal or external. For example, if the asset maintenance part of a manufacturing business shifts from scheduled maintenance to a more proactive approach powered by lead indicators of upcoming faults and issues, we would classify that as a change in the internal business model, specifically the key activities and value proposition of that maintenance function inside the business. An external innovation could involve supplier relationship changes or servitization, as in Rolls-Royce, Power by the Hour, Chapter 4. Wherein the innovation crosses or bridges the firm's boundaries.
3.
There are many ways to define the business model. One suitable approach would be the business model canvas, 5, which breaks down the business model across a range of key elements including infrastructure, key activities, key resources, and partner network, offering value propositions including price, efficiency, customer experience and outcome, customers, customer segments, channels, and customer relationships, and finance, cost structure, and revenue streams. For this book and the associated research, we have defined business model innovation as having occurred when any part of the business model canvas has fundamentally changed. There are numerous frameworks and methodologies for innovation. Over the past 2 decades, many organizations have moved towards a customer or human-centered design (HCD) approach epitomized by the IAG case study, which focuses on unmet needs, in addition to the traditional focus on reducing waste and inefficiency in the incumbent business process. The critical reason why we wanted to focus on the innovation process itself was because of the broader range of potential innovations that are possible to create
using AI and cloud-based technology.
when overlaying these new capabilities against a typical HCD design process model used in business. These new possibilities are both a blessing and a curse for business leaders. These design process phases are: discover, understand the issue rather than merely assuming it. It involves speaking to and spending time with people who are affected by the issues. Define. The insight gathered from the discovery phase can help to define the challenge in a different way. Develop. Give different answers to the clearly defined problem, seeking inspiration from elsewhere and co-designing with a range of different people. Deliver. Involves testing out different solutions at small scale, rejecting those that will not work and improving the ones that will. 142 Innovation. The focus on unmet needs particularly comes through in the discover and define phases, where there is a significant emphasis on looking outside the current ways of working and
Blend customer need.
the flexibility and optionality inherent in these new technologies means that there are far more new potential solutions to consider, particularly in the develop phase, and there is a critical need to carefully rule out potential options as you enter the deliver phase. How do these innovations practically impact the business model? To illustrate the impact of AI and cloud technology against specific types of innovation and potential business model options to be considered, we have highlighted the way in which some of the technology innovations covered in the previous chapter can be applied against Doblin's 10 types of innovation. 6. These were summarized in Chapter 1 and are re-listed below. Category type overview. Example: AI or cloud innovations. Configuration: profit model, the way in which you make money. Creation of marketplaces, platform business models. Enabling niche specialization within a value chain. Network connections with others to create value. Simplifying and reducing the friction in partnerships and joint value proposition structure. Alignment of your talent and assets. Enabling new organizational structures with an increased ability to specialize in certain areas, while outsourcing others. Process signature of superior methods for doing your work. Leveraging improved data and decision-making using AI-enabled automation and process controls. Offering product performance distinguishing features and functionality. Adding new capabilities to proactively provide service to a customer through AI product system. Complementary products and systems using cloud and APIs to simplify partnering with third parties for added value. Innovation. 143 Category type overview. Example: AI or cloud innovations. Experience services, support and enhancements that surround your offering. Leveraging customer and
Service data to drive improve.
Vehemence in customer experience and R&D spend. Channel: how your offerings are delivered to customers and users. Offering both a multi-channel experience,
Web
app, which is personalized to the needs of that specific customer. Brand representation of your offerings and business. Taking a proactive position in the use of these technologies as part of
e-brand.
Apple's stance on data sharing and data ownership. Customer engagement. Distinctive interactions you foster. Leveraging customer use data to prioritize the services enhancement and future engagements. Netflix's recommendation engine. In practice, many new business models will adopt more than one of these types of innovation, increasing success likelihood. For example, when Netflix disrupted its DVD delivery business model and developed an online streaming service, that was an example of its profit model, as the economics of running a web-based distribution were fundamentally different. Channel experience, as users could use the service on demand, and product performance, as you could immediately access orders rather than wait for them to arrive in the mail. PEXA's mortgage settlement process innovation is an example of a new profit model as a new facilitator of a traditional value chain network, as the creator of a new standard process for mortgage settlement process due to the electronic and traceable nature of the transaction flow and product system, as banks and lawyers could offer a better service and faster settlements by partnering with PEXA. Alternative approaches for innovation and venture development. A broad range of approaches have been taken for the development of new innovations and ventures, for example 144 Innovation, internal C. Appability uplift, where the business unit develops its own capability to design, test and deploy new innovations, typically in the core of the business. Accelerators, where a dedicated multidisciplinary team accelerates the validation of new business models or the commercialization of a business mode. Incubators, where a dedicated multidisciplinary team help develop net new solutions that leverage capabilities or assets from the core business. Corporate venture capital, where direct investments are made into external organizations, typically with the purpose of creating partnerships across an ecosystem. For the purpose of developing new solution. Crowdsourcing, where an organization announces external challenges together with incentives to develop new solutions or challenge in progress innovations. Each of these approaches offers pros and cons across different parts of the innovation cycle. However, a recent report 7 highlights a range of lessons learned across innovation and venture development in Australia. 1. There is no one-size-fits-all innovation and venture development model. The approaches need to be considered in the context of the organization, and knowing why and how to deploy each of them selectively is key to their success.
2.
The support of the CEO is key to the success of these innovations, as is the pull from the broader business, who will need to see value for their functions in the innovation and venture development process.
3.
Long-term success requires a portfolio focus, supported by clear success metrics, stage gates and long-term commitment. Conclusion. In summary, our view is that a structured process for developing innovations should be used to select and effectively manage the broad range of potential business model innovations that could be pursued. This statement has always been true, but the nature of the disruptive technologies covered in this book mean that there are more potential ways to innovate. There is a greater need to effectively prioritize those innovations, integrated with technology enablement and effective transformation.
โน้ต 1 www amazon.com เอา Tentai Innovation DCI Apply Breakthrough eBook DT B00DZLBHU 823 สัน D Chloe M 2015
Innovation and Entrepreneurship.
Oxford University Press www com เอา Book Higher Education Management and Marketing 9780190300647 Innovation and Entrepreneurship eBu Innovation 145 3 Davenport T Bean R 2021 December
Catching up fast by driving value from AI.
MIT Sloan Management Review https://Sloan Review NIT
Adu article Catching Up Fast by Driving Value from I4C Argus.
3 สัน D 2021
Strategic Leadership for Value Creation.
Palgrave Springer 5 Bucket A T B คัญญา V T Oliveira M G Rosenfeld H 2011 Business Model Element for Product Service System in Hasselbach J Herman C. S.
Functional Thinking for Value Creation.
Berlin